Okay, so here we are. We are in a little ecosystem. Remember, ecosystem means living. And we have all kinds of living things around us here. Of course, all the vegetation. But we got squirrels. Whoop, there goes a woodpecker. Okay. Living and non-living. Okay, so all the living things we notice right away. Some of the living, non-living stuff kind of is invisible to us, not because it's invisible, but because we don't pay much attention to it. But here's a bunch of non-living stuff here. Some soil, this air that's all around us, the sunlight coming down through the trees. So ecosystem, living and non-living, interacting together. Now, an ecosystem needs, from our perspective right now, two things to keep it going. It needs an energy source, because everything needs energy to keep it going, once you stop having energy, you cease to be living. Okay? And we need nutrients. An ecosystem needs nutrients, okay? So our energy source here on the planet's surface, where we live anyway, as you all know, we've already talked about, is this lovely sunlight, okay? Diffuse as it is today, it's still there. And the nutrients, well, the nutrients are in many places. The nutrients are locked up in the tissues of this dogwood. Okay, the nutrients are down here, locked up in these dead leaves. The nutrients are in the soil. The nutrients are in the blue jay, who is screeching behind me. The nutrients are in me and you, okay? The nutrients are the actual chemicals locked up in our bodies, locked up in planet Earth. The physical atoms and molecules, okay? So, energy is more ephemeral than that. The sunlight that we need. Not a solid substance we can put our hands on, but nutrients are. So we've got the energy and we've got the physical nutrients that organisms need to keep themselves, to build their bodies, and the energy to do so, okay? So, what we're going to do with this part of this unit is look at the differences in how nutrients move through an ecosystem, perhaps moving from this state down here back up into this state up here, into this state here, and then ultimately back here. And what you need to recognize is that's a cyclical movement. Energy does not move cyclically. It is a straight line, okay? And we'll talk about that. But we're going to first talk about nutrient cycles, how these building blocks, atoms, molecules, if you want to think of them as Legos, that is how I always like to think of them, these little building blocks. You dump out your Lego blocks and you build something with them, and then you don't just toss them away, or they don't stay in that form, that tower forever. You break them apart and you use them for something else. We are always reusing the atoms and the molecules that we have to build new things, whether it's this thing or something else, okay? So we're going to talk about that. We're going to focus on nutrient cycles first, okay? Okay, we are back inside from being outside in my little ecosystem in the backyard. And I want to start with this slide here, because this kind of helps us get at some of the core issues I was trying to get to outside. We know what an ecosystem is, but what I want you to focus on is an ecosystem as being a transformer of energy. The big picture is that we have this energy coming at us from the sun that you and I cannot use, but there are other things that can use it, and they transform that energy into a usable form for us. They take that light energy and transform it into chemical energy that we can then access. So transformers of energy and then processors of matter that take nutrients, so this is the nutrient component, out of the soil, out of the air, and change their configuration again so they can be accessed by other organisms. Ecosystems are self-sustaining in that they could do this over and over and over as long as there is an energy input. Okay, so if there ceases to be an energy input, then you have an issue. If the sun is kabooey, then we've got a problem. Kabooey. Anyway, ecosystems capture energy, they transfer it to other organisms, and they also have to be able to cycle nutrients. Okay, and now what we're going to talk about is the nuts and bolts of that. How does all that occur? Okay, so we of course know we've got the sunlight as our input of energy. It's a one-way flow. We'll talk about that more in a little while, but this is where we want to get at right now, that nutrients cycle. The nutrients that are here right now on planet Earth have always been here on planet Earth, and they have been used by organisms over and over, time and time again. Just like your Lego blocks that your parents might have given you when you were a toddler, you use them over and over and over again to build different things. Nutrients are the same way. Okay? What are we talking about when we're talking about nutrients? Those physical atoms that build bodies, that build living things. Now, some important ones are listed here on the slide. Nitrogen, phosphorus, carbon, water is a nutrient. There's many nutrients. In living things, there are some that play much larger roles than others. These are big ones. Carbon, hydrogen, oxygen, phosphorus, nitrogen are the biggies. And of course, we've already talked about energy. We'll get at that more later. Now, a generalized nutrient cycle. Okay? There is a source for a nutrient in the earth. Okay? And then living things get at that nutrient from the earth, and then they pull it into the cycle of life, and then it's sometimes returned to the non-living original geologic source. Sometimes it just keeps cycling through living things over and over. So let's take a look. Abiotic reservoir means a non-living reservoir of some nutrient. Maybe we are talking about carbon, or maybe we are talking about oxygen, or something like that. There is an abiotic place where you can get that. Maybe it's the air. Okay? And there are geologic processes that don't even involve living things that allow those things to cycle through certain transformations without life being present, but that's not really what we're interested in here. So there is this abiotic source, some geologic source for some nutrient, and somehow that nutrient enters the food chain, usually by being made available to some producer. What do I mean by a producer? For us on planet Earth, on the surface of the Earth, we mean, generally speaking, plants. Perhaps if we're in a pond, we mean algae, but some producer, something that is going to be the initial harvester of energy, of certain nutrients that are made available, and so on. So producers are what we're going to talk about. Now, those producers, those plants, those algae, then lock up those nutrients in their tissues, and they make them available to the consumers that eat the producers. Consumers like a squirrel, a rabbit, a dog, a cat, a you, a me. Okay? So, now, we don't just end there. If we did, all the nutrients would eventually get locked up in all of the consumers, and that would be the end. We've got to have some way to return these nutrients. We've got to put these Legos back in the box so we can spill them out again and make new things and keep the cycle going. So, decomposers play a vital role, and decomposers can impact all these levels of the food chain. When a consumer dies, decomposers will come in, it keels over in the woods, the decomposers break down its body and return those nutrients to the soil so they can be picked up by a producer again. Same thing when a producer dies. Okay? So those things would go back into the food chain. After being decomposed, we just run them right back up the food chain, and so we kind of keep a cycle going around and around in that way. Okay, so decomposition, as it says here, connects all of the trophic levels together. Trophic levels meaning those levels through which energy passes and nutrients from producer to different levels of consumer. Okay, sometimes the decomposers will eventually just return these nutrients to the abiotic reservoir. Maybe they release carbon into the air. Maybe all of the material that they release doesn't get taken up by a producer right away, so that would just get returned back to the environment. Okay, so what we're going to do is go through 3 different cycles, the first being the carbon cycle, and talk about how these nutrients pass through these cycles. I'm going to stop this here so you can, we'll take a pause, and then the 3 cycles be in a separate video, separate screencast to themselves. Okay? Thanks a lot.